Now we're going to step it up in a couple of ways. Use the method of cylindrical shells, again, to find a volume, generated by rotating the region bounded by the given curves about the x-axis this time. And our curves are x plus y equals 4 and x equals y squared minus 4y plus 4. What I'd like for you to do is go ahead and just sketch the region and come back when you're done. Here's our region. Hopefully you recognized y squared minus 4y plus 4 as a perfect square trinomial or thought to complete the square. In any case, we have a parabola and a line, and we're looking at the region between the two. We're going to rotate about the x-axis, which means that I'm thinking about a representative rectangle that is horizontally oriented, which means that we're going to integrate with respect to y. Now let me just quickly draw a cylinder, and we're thinking about the representative rectangle as forming the cylindrical wall. And in order to set up the integral for volume, we need 2 pi RH, and then in this case, it's with respect to y. I'm going to start to pull the 2 pi out in front of the integral. It just makes sense to me to do that. What I'd like for you to do is come up with the limits of integration. Remember, this is in terms of y. And then see if you can find a radius for this scenario and a height, and come back when you have the integral set up. I decided to go ahead and develop this with you, or in front of you. When I look at this representative rectangle, I think about x2 minus x1, right? This is a horizontally oriented rectangle, right? And x2 is going to be the larger of the two function values. That would be the rightmost one. So x2 minus x1 for the height of my cylinder. And then the radius of this cylinder, if you have it, that's great. If not, I mean, it is tricky because it's almost too basic to think about. The radius is the distance from the x-axis. And by definition, a distance from the x-axis is what y is. So here, the radius is equal to y. So we're looking at 2 pi RH. The radius is y. H is going to be 4 minus y, because I need to take this x plus y equals 4 and solve it for x, right? I want something that has y in my expression. Minus y minus 2, the quantity squared. That's what we're saying is our x1. Times. Now, just now I kind of lost what I was doing. And what I did was I glanced up here. What have I done? I've got r done. I've got h done. Oh, then I just need a dy. As far as the limits of integration, we're looking at the y limits for the gray region. And I think it's pretty clear that this goes from 0 to 3. To confirm that, we can set y minus 4 equal to y minus 2, the quantity squared. Of course, I meant 4 minus y. I'm not trying to change anything up there. Solving this for x, 4 minus y. Okay. Now we have confirmation that y is 0 or 3. As far as integrating, simplify the integrand, distribute, use the power rule. And when all is said and done, we get that the volume is 27 pi over 2. This gives rise to something we can say in general. When rotating a region between two curves, f and g, over an interval from a to b, and in this case we'll say that x is bigger, or excuse me, f is bigger, then the height is going to be the difference between the two function values. But the formula for volume itself doesn't really change. The integral from a to b of 2 pi x times the height function dx. That's assuming that we're rotating, of course, about the y-axis this time. And of course, if our axis of rotation was the x-axis, or horizontally oriented, so that we were looking at functions of y, the height would be the same, large function minus small function. And then x changes to y, And we would be integrating with respect to y, so the width of that rectangle is delta y.